Hello, this is Michael Rees. Welcome to Ad Hoc, a virtual talk series. I'm a sculptor and new media naut. I'm here to have fun and sharp conversations with some of the smartest people in art, technology, and sculpture. My interests and those of our guests will range far and wide and focus on making and the artist's role in our current era. We'll be talking to artists, curators, designers, and more. Welcome to Ad Hoc. Well, great.
All right.
So, welcome.
Thank you.
So now you're a doctor, of course. So you're this. I want to introduce Dr. Jose Luis Garcia del Castillo y López, and you've agreed to talk to me today, which I'm delighted about. And why don't you introduce yourself and talk about when for example, we heard you speak the other night at the university. And you said, I started as an architect, but I don't really define myself as that any longer. And so I'd love to hear you talk about sort of your switching roles, your hybridization, your morphing into different ways and means.
Poking your finger in the wound, huh? I am happy to explore that wound. Yes, so thank you. Thanks for hosting me. And I'm very happy to be here. Yes, I have a very long name that is sometimes preceded by the doctor prefix, but I'm just not the right kind of doctor for these times, unfortunately. I'm the other one, the academic kind.
Yeah.
I have many hats, and I guess I'll start with the architecture hat. So I actually studied architecture back in Spain. I'm a registered architect in Spain, and I used to work in structural engineering for many years. And it just so happened that I think somehow in my training or my education as an architect, there was a lot of frustration about how I thought architecture was taught to me. So this idea, the whole idea of like the critique model and the whole idea of somehow how architecture is branded as you're either designing museums every day or you're not a great architect. Like that was a little bit of the bottom line, sort of. And I couldn't really relate to that because I knew that most of what gets built every day is housing, and I barely did any housing project when I was studying, which was a very strange situation for me. But also I was I don't know, I knew I was a creative person. I knew I wanted to express certain things, but I think through my studies, I struggled with buildings being the medium that I used to communicate the things that I want to express, I think. So I was working professionally as a structural engineer for many years, but it wasn't until trying to customize the tools that I used for manipulating lots of data, which is what you basically do when you're doing structural design. It wasn't until I got into customizing the tools and being able to hack the software that I was using or do very complicated spreadsheets that felt like almost like writing software or those kind of moments that I started thinking about computation as something that could help me in my work. And then coincidentally, back in the times, I discovered this like underground current of people in the internet that were using computer programs and code. They were writing their own code to make cool animations, art experiences, really fancy convoluted 3D geometry that I was super excited about. And I didn't know that could be generated writing computer programs. So I got really fascinated about that.
Just let me ask quickly, what year is this we're talking about?
We're probably talking 2008, 2009. Wow. And then I went down part-time in my job to do a master's on top of that. And then when I did my master's, I got really excited. So I quit my job and then I worked as a researcher in the university for a year. And then I got accepted to study another master's here at the Graduate School of Design at Harvard. So that's when I moved to the US. This was 2010, I think. And then then the first year, basically, I was like, okay, this is what I want to do for my life. And that's when I started calling myself a computational designer, whatever that means, which to me is I am a creative person. I am a designer. I like thinking about making physical things. I like thinking about making software. I like thinking about creating installations, experiences, and also buildings still. But my medium, my tools, or the tools that I relate to and that allow me to express all those things are typically computer code.
Now, did you also study programming and did you do any formal study with
I have never formally studied computer science besides an introductory course that I took in 2013 when I already knew how to code, but I was just curious about computer science as a field, but now everything has been pseudo self-taught. Always.
Which is quite interesting. And then you've also worked on a variety of projects where you've written code and produced code for those at a professional level, right?
Yeah. So I have worked for a large company called Autodesk, which is a company that makes a lot of the software that we use for design in the AEC industry, but also for visual effects, for fabrication, et cetera, et cetera. So for example, if you're more in the art sculpturing kind of world, there's this software called Power Mill, which is for designing the toolpaths of a robot or a CNC router to mill something. That is also one of the products that Autodesk has.
Right.
I worked for 3 years as research engineer for the generative design team, which is a team that specializes on creating tools that allow architects and designers who use Autodesk products to do algorithmic modeling, which means it's a software specifically that is designed. If somebody has done Grasshopper, it's similar to Grasshopper. It's called Dynamo. It's basically a visual programming interface that allows you to create procedural geometry, but using a visual interface as opposed to writing code. So it's a kind of like a middle ground between not coding anything or writing actual textual code. Right. It's a very popular framework for people who are trying to begin or get better at computation within architecture.
So Dynamo is the name of that program, but also it may be a little bit inspired by Grasshopper that's connected to Rhino 3D, right? I mean, that was one of my first experiences with visual programming or visual coding was the Rhino stuff. But there's other programs. It's this tendency to try to sort of make programming a little easier, a little more accessible through a visual interface. That's been around for a while, right?
It has, yeah. Visual programming languages have been a thing since the 90s, roughly. It's just that they have kind of exploded in popularity in the early 2000s and now in the 2010s. They're very widespread as a model, as a metaphor in a lot of software. If you're into, for example, experience design, there's this software called Touch Designer, which is also a node-based kind of editor with boxes that you join with cables and they represent operations. This one is more oriented towards computer graphics, 3D modeling.
Well, a lot of people, I mean, our podcast here is going on this sculpture.org website. And a lot of people might be, experiencing some of what we're talking about for the first time. And it might be frightening to them because, they love to make things by hand. Sculptors typically do. I'm a little bit of an outcast that way. I love to make things with machines, but still, nonetheless, they might be a little intimidated. And I think that kind of hits on something that you're really interested in. And that you talked about it the other night, the notion that people, basically the way computer manufacture is designed to run is that you input a file and then you do some very specific things in terms of programming. Then the machine, you do it offline. The machine, then you load it into the machine, you start it up, the machine then produces. 3D printing is that way. Robot carving typically is that way. And it's maybe really similar to just sending a print to your printer. You're not doing any of the printing. You're not interacting with it in any way. The print is just coming out. But you're interested in changing that, right? This is something you've been very involved with.
Yeah, I see you know me well. Yeah, one of my research lines, if you will, is how we can bring making, digital making, back in the hands of human beings, in a very broad level. So it is true that the process that you have described, what I called offline programming, or typically the model that is provided by 3D printers, right? It is a model that where basically your agency as a designer, as a creator, is encapsulated in whatever digital software you use to create a 3D model. That is a very abstract thing, very digital one, right? For which you have no haptic feedback, you don't have a visual scale of the object in the real world. It's kind of, it misses a lot of the interesting things that allow you to make decisions when you're making things. So the problem with the 3D printing model is that it's very good for production, but when you want to make things and make decisions while you're making those things, it's not great, because since you are reduced to the digital environment,
Yeah.
then at some point you stop making or designing in the digital environment and you press a sequence of buttons that lead you to a file that you put in a 3D printer, you press the button and you hope the machine does the object, but you don't have any participation anymore. And this is a model that is consistent in many of the digital manufacturing machines that we have around us these days. To me, that this is great for making things in industry and for production grade objects, but for art and for people who are inquiring and experimenting with the tool themselves,
Right.
is very constraining. And I want to link this back to the old times, the romanticized times of craftsmanship and the human tool unison of the artisan who is extremely skilled at the tools, is so skilled that actually has opinions about how to change those tools and adapt them to their own thinking and their own workflows. That today is very difficult because changing an industrial machine requires a lot of engineering background
And a lot of money.
A lot of money and a
Yeah.
lot of guts, if
Yeah.
you will, you know?
Right. Right.
So the easier low-hanging fruit is typically to change the software that runs those machines, which also requires a lot of technical expertise, etc. But it's a much safer endeavor and a much more attainable one, at least in my opinion. I guess I'm saying this because I've done it and it's doable. So that's why a lot of what I do is I create software environment and code libraries and things that try to hack these machines and allow them to be used in real time and communicated in real time, which is definitely how they're not designed to be. An industrial robot for a car manufacturing company is not designed to be interfacing in real time.
They don't want any improvisation on the floor.
No. They want like precision and calibration, and everything has to be exactly how it's supposed to be, you know, for very valid reasons. Don't get me wrong. It's just that when you use that in other contexts, then you want other kinds of possibilities. So I have typically done this through open sourcing tools and providing libraries out there in the wild for free, because thankfully I have a job in academia that allows me to contribute knowledge to the world, because that's what we like doing, you know.
So one project that comes to mind when you're talking, and a project that I just absolutely adored the other night that you showed, was the wax printer. Can you go through that a little bit and show us that whole process? I think it's just really, and then of course I also want to see that video again of you working with the robot to carve ceramic blocks. But let's start with the wax.
I am very happy to do that. So the project that Mike is referring to is a project that I did a while ago when I was a student. And it was a project where the brief was trying to design a machine to make physical things in a novel way. The project was called Expanded Mechanisms and Empirical Materialisms, because it was trying to find.
Wait a minute, expanded mechanisms and material
and empirical materialisms. Yeah.
Beautiful.
And so because the project was about trying to find where a new correlation between a new machine and a particular material process could create a new interface. Nevertheless, I'm getting into the weeds. So basically, we were very excited about 3D printing. This was many years ago, so 3D printing was still kind of novel. And we were inquiring about other ways of non-standard 3D printing. So we thought about wax as a material that we hadn't seen anyone 3D printing with wax for many reasons. It's very difficult, it's a liquid, etc. So we thought about the interface between hot wax and cold water as a potential to, you can, if you create some kind of container where you start like raising the level of water, and that becomes like the layer where you deposit wax, and maybe you can start creating form, etc. So the first thing we did to experiment with this idea was we created these handcrafted experiments where we took a bucket of water and we started depositing, melted wax, and we were okay with the results, but not very positive. This thing that you're seeing here was supposed to be a perfect cylinder. So, so you can realize how we were perhaps a little skeptical. And also we had like visions about what this machine could look like. So we were thinking about, yeah, well, maybe it's like a typical 3D printer. It has like a gantry that moves around and deposits, and then the water level starts raising. But maybe it doesn't have to be that. Maybe it's some kind of like more autonomous, mobile sort of robot that just squirts wax around and perhaps like blends colors, CMYK kind. We were very speculative about and very open about what we wanted to do. So we actually settled for, okay, let's build a 3D printer, and it's going to be like the classic gantry with pieces moving, etc. But we were pushing through the project, and we were doing, and it was like, we got all the pieces working, we got the gantry moving around, we got the pump for the wax, we got the heating system, we even had some color mixture options, but yet we were not very satisfied with the results because we were facing some kind of conundrum. The conundrum was, if we are successful at making this machine, best case scenario, we're going to end up with something blobby and squirty, and it's not going to have the clean precision that typical 3D printers have. So if we're not gonna get there anyway, why do this? But most importantly, what we felt is that we were basically trying to impose a behavior and a form and a way of being into a material that didn't really want to be that way, given the results that we were obtaining, right? So for us, it was important to acknowledge that high-end technology and a lot of engineering, sometimes it's just not the solution. So it ended up being an exercise of humility and coming down to earth and be like, maybe we're not thinking of this machine the right way. Maybe instead of forcing the material into a shape that we impose on it, maybe what we should do is create some kind of other machine where we create space for the material to express itself and to be whatever it wants to be, and to manifest itself in its purest essence, if you will. I don't know. So that's where we ended with this other machine, which we call WX. So for wax, basically. The machine was not so much a machine, but it was like an experience. It was very, very analog. We thought of it as a sort of crafting table, if you will. The table had, the bench had a lot of different ingredients. So you could mix, for example, there were different kinds of wax. So there's soy wax, there's honey, there's a beeswax, and then you could craft your own recipe. You were the one who manually engage and interface with the material, because we thought that that closeness was important for people making things, right? So you could heat up your own, control the temperature manually, melt the object, and then you could also, and then there was this machine, there was this big tank with water with a tray that was perforated where you could situate your container. You could also mix some dyes into the wax and give it some tint, give it some coloring. And the only real digital if you will, the only digital part that this whole setup had was basically this controller that was on the side that allowed you to create a sort of speed map about how fast or how slow in time this tray was going to be sunk into the machine. So what you see now is the machine starting to work, the tray starts to sink into the water, and the container with the wax is starting to go into the water tank. The beauty about this machine is happening because of one very particular property of wax and water, which is that wax is less dense than water. So as soon as the whole container immersed, the wax started floating up into the water. But at the same time, because of the coldness of the water, it started crystallizing into this cavernous shape of whatever. I don't know how to define this form. But the beauty of it was that
inexplicable beauty.
There's some inexplicable attraction, something so compelling and so satisfying about this process that you see live, like emerging in front of your eyes, right? Without you being opinionated about what this should look like beyond basic features like the form of the container, the form of the base, or the color of the mixture, right? Or the speed, because it turns out that the changes in the speed actually had quite a lot of effect on the texture. You can see here the effect of that texturing, It ended up being a super interesting thing, but it was mesmerizing to just sit there and observe these forms, these really complicated and meticulous textures arise from these objects. But most importantly, what we were very happy about is that we felt that this was what wax wanted to be like, interfacing with water. This was not us telling it what to be. It was just the nature of the material, the temperature, and the combination of all these systems, which for us was an example of emergent beauty, of emergent form, something that we could not even have realized or imagined before we studied it for the first time. And we could not get enough of making more and more of these objects. Turns out that there were a lot of very small things that affected the shape, like the speed of the object, like the material, beeswax and soy wax gave very, very different patterns. The temperature of the water, so if we did it for a long time, the water was hotter, so it created more smoother forms. So there were a lot of these like very nuanced parameters, which is exactly what we wanted to explore in relation, again, back to this idea of craft and back to this idea of like the artisan knowing their tools in such an intimate way that they can start working around them and mastering them in this bidirectional relationship.
But I think you hit on there's a couple of undercurrents here that are really profound. One is the notion of emergent qualities, right? Mm-hmm. That you don't have an anticipation, or you set up a set of circumstances and you're going to allow the subject of those circumstances to express itself, right? Mm-hmm. And then I think the other sort of implication here is something a little bit like panpsychism, that material, or that all that consciousness, I mean, this is a recent theory that people are working on, et cetera, but that mostly material, one of its primary qualities is a kind of consciousness, Now, we don't understand what that is or what that might mean. It's hard to say, oh, I'm talking to a rock, it has will, it has thought, it has these things. And yet at the same time, I think artists and architects, anybody that's worked with their hands, they understand that the material talks back. Mm-hmm. You can never impose your will wholly and completely onto material. Mm-hmm. It will always assert itself in some way or another. And how you respond to that will depend on whether the thing lives or dies. Mm-hmm. In an aesthetic sense, I mean,
There's this modern philosopher called Manuel de Landa, who also comes from the architecture kind of discourse of things. But he has some beautiful books about this very particular concept, the idea of the material, what he calls the morphogenetic potential of material, which is ideas drawn by the laws and 1,000 years of nonlinear history. So it's a very interesting current of thought, actually. And it's a lot of what, for example, carpentry is a very good example of that. You can think that the wood is kind of this material that allows you to do whatever you want with it. But if you're a carpenter, you know that there's many more nuances to that, you know? So the skilled carpenter is the one who can actually take advantage of the knots and the direction of the fibers and those kind of like nuances for their advantages to working with that as a substrate, you know?
That's exactly right. And, I mean, I think, one of the ways that you and I have known each other is that you participated in the Digital Stone Project and did, we met at Harvard when we were giving presentations and doing all that kind of thing. But you also, what I love about your approach in some sense is that, when you use a robot in the sort of instrumental way to realize a physical form, and you want it to be repeatable, and you want it to be very, very precise, and you want it to follow, to realize your form, you kind of are, it's like a hammer. It's a tool like a hammer. And basically, the only thing you're ever going to get out of that robot is what your expectations for that robot are. Whereas now you're opening up this world where other things can start to take place. Other things can happen. I mean, I did want to talk about the ceramic piece, but let's take a moment. Why don't you show the project you did with the stone? And, I think that's quite an interesting piece, and it's a good segue. And this is why maybe you're not an architect, you're not a computational designer, you're a sculptor, you're a person, you're a polymath, you're a person who does many different things.
Well, I don't know about that, but I'll take it. Thank you. So let me show some of that too. Yes. So the project, well, sorry, I'm going to call these pieces because in this one, I was an artist. I wasn't an architect, so it's not a project anymore. It's a piece, right? That's when I started feeling like an artist, actually. So the pieces that Michael is referring to are two sculptures that I created as part of my Digital Stone Project residency in 2018. The Digital Stone Project is a nonprofit that organizes workshops in Italy every summer, and it's for sculptors who are willing to explore marble as a medium in partnership with robotic fabrication. So I was part of Autodesk at the time, who was a sponsor of this event, and they sent me to do more of a research residency and explore what could be done, new ways of connecting digital making tools with machines and in the context of marble. So I showed up there, and they took me to this like amazing quarries of marble in the back of Carrara.
Absolutely brilliant. Yeah.
It was one of the most humbling experience and beautiful experience, because there's something so architectural in a way to these environments that I was just compelled. And then it was very interesting also to observe like the amount of industry and the amount of technique that was also involved in extracting this material and working it, which I thought it was great. So I showed up there and I was given the brief to create some kind of new interaction between digital tools, physical tools, etc. And that's what I wanted to explore. So I was very inspired by this video that I found on the internet called Il Capo, the boss, which is basically this person that works on marble quarries, and he uses hand gesturing to instruct their colleagues with the excavators on how to move the actual excavator spoon and move the pieces out, etc., because they cannot really see it. So he's the one that commands the machines or the people who run those machines with his hands. So I was very inspired by that concept, and I was like, can we think about making physical sculptures by using hand gestures and using our mobility, that freedom, to make physical artifacts? So the first thing I did was, well, the first thing I'm going to do is I'm going to create some digital tools. So I wrote this plugin for Dynamo, the visual programming language we're talking about. It was an extension of a project that already existed. So I took it and adapted it to Dynamo, and so that I could interface with what's called an HTC Vive controller, the typical joystick that you use for virtual reality. I wasn't interested in the headset, but I was interested in the joystick because it allows you to track your motion in real time in 3D. With that, I was able to create a system that tracked my motion in three-dimensional space very easily and brought it into a computer-aided design environment so that I could turn that into geometry and start working with that. And then I did some experiments. It feels like it was free and flow, and it allowed me this expressivity. So I was happy about that. But then I was like, okay, what do I do with that? So the first thing I thought was, well, maybe I can actually create a piece that reflects that freedom, that reflects that elegance of the trace in three-dimensional space, like the gesture, right? So I thought of using this controller to create a gesture, if you will, like a motion in three-dimensional space, record that motion, and then be able to mill this piece in a as thin as possible of a lamina, right? The problem I found very immediately was that, and we were joking about this the other day, is that turns out that my gesture in three dimension is not as elegant as I thought. It's as bad as my handwriting, which I also don't like at all. And that's why I use, I type things on a computer and I print them on paper and I send them in the mail, right? Because you want elegance, precision, you want something that is readable. Turns out that it's the same for the hand. This that you're seeing here is this is probably the best recording I could get out of my hand, the most consistent one, and it still looks pretty crappy. It's not that elegant, smooth, sleek gesture that I had in my mind. There was quite a huge deal of post-rationalization that I was trying to also control with algorithms. How can I take this wobbly gesture and try to make it more aligned to a vertical axis and more contained and less? But at the end of the day, I was not very satisfied. So I ended up working with a mixture of the gesture plus some really, really rationalization algorithms to create what I wanted, which was this sleek, elegant, like gesture in three-dimensional space, right? And then I was able to just give it like a tiny bit of thickness, as much as the engineers in Italy suggested me to do, which was roughly half an inch. And then we were able to create this 3D object, which represented the gesture folding into itself. And we were able to, with the help of my colleagues in Italy, who were very skilled engineers and they really know what they were doing material-wise, we were able to program the robot to do all this tool pathing, which in this case was predetermined. So in this case, we were using the offline model because in this particular case, there was nothing about the real time that I thought was advantageous. Advantageous, I'm not pronouncing that correctly, that I had any advantage in this particular piece. And then I was very lucky to be bestowed this beautiful piece of marble that was just extracted from the quarry. It's called Arabescato Bagli, because since the piece was going to be so thin, we wanted to explore the idea of transparency or translucency in the material. So it turns out that this particular marble is well known for being very translucent. So it won't show on the video, but actually the final piece was extremely, extremely translucent. You could put a flashlight on one end and put your fingers, and you could see through your fingers through the material. It was beautiful. It was really, really nice. It took probably 2 full days of milling because it had to go really, really slow to avoid cracking the material. But we ended up with this piece, which I don't know, I was very happy about. And if you see it physically and if you touch it, there's something so attractive about it. I don't know. I thought I was very satisfied about it. Unfortunately, Or fortunately, it's part of the Autodesk collection at the Technology Center in Boston. So I don't own it anymore, but it's actually up for exhibit whenever we are back to normal. So if you're in Boston and you go to the Autodesk Center, you will be able to see it.
Great. It's always better when somebody else owns it, I promise you.
Yeah. Should I talk about the other one or?
Sure, why not?
All right, so this one I was very bored. So I thought I was going to be doing one piece only, but then I was very bored when the milling was happening. So I thought of doing a side project. And the side project was thinking about how in the quarrying process, there's so much material and so much marble that is discarded just because it has cracks, it has veins, or it's just so abundant that it's kind of given for granted there. And they even throw these pieces to the river and abandon them. It becomes construction filler material for roads. So I thought of digital workflows that could allow us to give some of these pieces a second chance. So I thought of an integrated digital workflow that went from 3D scanning any rock, then doing what's called a propagation pattern on top of the digital model of that rock, and then patterning, grooving that shape on top of the rock to give it unicity, to give it a new character, and to bring it back as an object of desire. So I did some testings. I'm not going to get into this. There's a lot of rationalization and work that needs to go into going from a 3D scan into an object that has low sample enough that you can work with it, and then different kinds of patterns and groupings and clustering. So this is all a little too technical, perhaps. But the long story is that I pitched this idea to my colleagues there, like, hey, I want to fish a rock from the river, put it on the robot and groove it. And they were like, fine, let's do it. And I was like, seriously, you want to do this? Like, hell yeah, let's do this. So we took a rock from the river, we put it on the robot, we 3D scanned it, we reconstructed it digitally. And then once I had a digital object, I was able to create an algorithmic workflow to create a grooving maze pattern propagated on top of that surface. And then doing some simulations and some checks to make sure that everything was not going to generate errors, I was able to 3D print, if you will, this groove on top of the rock using the 6-axis potential of the robot, which is something that perhaps with a 3D printer or with a regular 3-axis router, I would not have been able to do. Making sure that the grooving was always perpendicular to the surface. This was my favorite piece. It was technically way more interesting and challenging than the first one, but and it's also an exhibit at Boston right next to the other one. But people typically pay more attention to the larger one for some reason. I don't know. It's also
drama. It's all drama, baby.
I know.
They love the drama. That skinny, and oh my God, it's so thin. You can almost, it's like a tissue. It's fabulous. But I love this one. I actually love this one as well.
I have to admit, it's way less sexy when it's dry. So there's the water really gave it a really nice touch.
Right, very nice, very good. Well, I thought it might also be, there's a couple. Your work is so interesting to me. There's a couple of things. There was the ceramic piece that you did where you really worked directly with the robot. You were the robot's assistant, so to speak. And it kind of reminds me of the famous Walt Disney animation, the Sorcerer's Apprentice. You were like the apprentice to the robot, which I thought was a lot of fun. But also it has another quality that I think is really interesting that you embrace. And that's the quality of failure. That you work on a project, you come up with an idea, you set the parameters for that idea, and sometimes it doesn't work. Now, I know it almost sounds like I'm leading you down a path, like I'm going to, hey, you failed. But the truth is that failure is both very generous because you're teaching other people about a technique or a path, and you're showing them what happened when you did it, almost setting up the possibility for success, right? Mm-hmm. Yeah. And so if you don't mind, I would love it if you spoke a little bit about the ceramic. Also, ceramic, of course, is a material that is really hard to master, right? Particularly digitally. really, really difficult. It represents all kinds of problems. And it kind of shows up the distinction between somebody who really knows ceramic and can make something by hand versus telling a machine to go do something with the ceramics. It's like, it's a fascinating little intersection of problems there.
I know, you're absolutely right. Let me share my screen again. I think you're referring to this project, right? So yeah, it is true that clay is a little bit like wax in the sense that it's kind of this untamable sort of material that it has a life of its own, and it's much, I mean, in a way, in the scale of things, it's much easier to work with and to predict than wax is. Wax was a shit was a wax show. It was a wax show, you know. but clay also presents a lot of challenges for digital fabrication, if you will, for making things with machines. It's just that they're small enough that a lot of us have actually tried to work with clay in a digitally mediated environment. So for example, this is a project that I did with some colleagues of mine in many years ago, like 10 years ago already, where we were trying to rethink the role of ceramics, and especially like the idea of, for example, a very well-known ceramic object for construction, which is bricks, right? Bricks is the standard, has been the standard in construction industry for many centuries, just because it's this serialized object that gets fabricated in a very cheap, very cost-efficient way. But the shape of a brick basically biases you towards certain shapes in buildings, right? And that's why buildings are square or orthogonal, and that's why. But turns out that when you want to do special things, when you want to do like more design objects or buildings, you rely on the expertise of a particular craftsman to lay the bricks in a particular way so that they generate um, these more expressive surfaces, right? So we were thinking about how could we design with algorithms and with more advanced fabrication methods, brick systems like the ones you're seeing here, where in order to create complex shape and complex form, we did not rely on the expertise of a particular labor, if you will, which is something that we are lacking of these days, but we relied on the expertise of digital technology and custom mass fabricated objects. So what we did was we generated a bunch of algorithms to go from any wall geometry that you can think of, which as much complexity as you want, to a set of patterned bricks, each of them with a unique shape, and each of them with a way of interlocking with each other that was unique between them, so that if you were to lay them in the correct order, they will sit naturally on top of each other without the necessity of any decision making or any expertise on site, right? The challenge here is that if you do that, then it turns out that each brick is different from each other. So you have to fabricate them, not in a serialized way, but in a customized way. That's where the robot kicked in, because the robot is programmable. The robot can make the same brick 1,000,000 times, or it can make 1,000,000 different bricks. It doesn't make a difference to the robot. The only overhead is the overhead of the programmer who needs to create 1,000,000 different programs for each one of the bricks. Fortunately, that's what I like doing, playing with code and playing with geometry. So for me and my team, that's actually where we could have a say and the kind of things that we were able to produce. So we generated the algorithms for the form generation. We generated the algorithms that generated fabrication instructions for the robots. And therefore, we were able to have the robot still cut fresh clay into the shape of each one of these objects. This thing that you're seeing here is like very, very sped up. So it was not as dangerous as it looks like. But just for the sake of it, just don't try this at home, okay? You probably need some supervision. So we tried a lot of these objects. We set ourselves to generate a doubly curved wall made out of 50 bricks, and each one of them with a unique shape, and each one of them had to be labeled so that it had to sit exactly where it was designed to. And we spent like, I don't know how many days in the basement of the fabrication lab at Harvard making these objects. And we ended up with a collection of these objects that look something like this. So we ended up with the 50 bricks. Where is the, yeah, so this was each one of the bricks. It had more or less this shape with small differences between them. And then this was a different version that we tried just for experiments. We did 50 of these guys and oh no, I've ruined it. We did 50 of these guys and we tried to assemble them into that wall that we had designed for. So these were all the bricks. And then, but then when we assembled them, it turns out that it was a massive disaster, huge downer, because they didn't fit into each other, because the tolerances were all over the place. It was a huge shit show again. The problem being many things. One of them, of course, you saw that the whole process that we use for prototyping, so it was very manual. So in the process of manipulating the object and moving it around, we were warping these geometries a lot inherently. But the biggest problem was that we were perhaps more acquaintance with all the robotics and the writing code and the algorithms part, but honestly, we had never used clay before. So when we were told that we had to have these objects sit and dry for a week before firing, we just put them on a plank on a table and let them sit for a week in the lab. What we did not think of was the fact that if you let a really massive piece of clay sit on top of a solid waterproof surface, what's going to happen is that the whole object is going to shrink, but the surface that is in contact with the table is not going to. So the deformation, the shrinkage of the brick, instead of being homogeneous in all directions, ended up being this kind of tapering, right? Which led to really, really big gaps and joints on the front side of the brick, whereas on the back side, it was kind of fitting much better. You can see an example of that here and here, for example. So that's something we learned from the process. That's something you learn from doing. And some professor or somebody could have told us, but obviously these things.
Maybe get some ceramicists because they're so knowledgeable about clay.
They are, and we had like, I have a long-standing collaboration with the ceramics studio at Harvard, who are experts in all these things. It's just that we were so ignorant that we didn't even ask about how we need to. We just thought, yeah, we're drying oil, we'll sit them here, and then when they told us like, no, you need to have them homogeneously dry out in we were like, oh god, we've messed up, you know.
Yeah.
So
but nonetheless, a beautiful project. You know what, I like to think of these things as kind of beautiful failures. And you know, the thing is that most people try to hide their failures, and what, you know, you're kind of doing it in a spirit where you know, it contributes to you're creating knowledge, you're creating more knowledge, and you're creating the possibility of the intersection between disciplines. You know, how many people really wanted to try to carve custom bricks and put them together in the past? You know, very good work, very good work. I love it.
That's what we try to do. We try to contribute to knowledge, even if it's by don't do this way, you know. That's also knowledge. Very
Somebody
valuable.
needed to learn not to play with the rattlesnakes, you know. Somebody needed to learn how to do that. Yeah. Hey, listen, we're kind of coming to the end of our time, but I just really want to say how grateful I am for you talking with me today. And I really admire your work and love what you're doing. And, you know, good luck with that in the future. How can people find out more about you and what you do? What's your social media tags? What's your website? That stuff.
Oh, I think, wait, let me, oh, well, so it's fine. So I don't do Facebook these days. So I'm more of an Instagram person. So my handle is my last name all together without spaces. So Garcia del Castillo. And I also have a Twitter, the same name. And I'm also on GitHub, which is this open source social network of people who write code. So I don't know how this video is going to be published, but maybe there can be links to that.
Well, there'll be links on the bottom. Yeah, there'll be links on the bottom. Yes. Yeah, at that point.
And I also teach, as I said, I teach technology courses at the Harvard Graduate School of Design. So I'm very Googleable. and you can shoot me an email there if you want to reach out. Because I'm also, full disclosure, I do a lot of collaboration with artists. So if you have a good idea, if you want to pitch it to me and maybe we can work together, I'd be more than happy to give it some thought.
Yeah, well, it's fantastic. And thanks for sharing all your work today. And I look forward to more stuff in the future.
Thank you for inviting me. When am I going to get the chance to interview you, Michael?
Whenever you like.
Tit for tat.
You know, as two professors, we're probably both, we're not shy about talking. Not shy about talking. But I'm always game, so just hit me up anytime.
All right. This has been recorded.
Yes, absolutely. Absolutely.
All right. Thank you very much. And thanks
all right, good.
Viewers.
The best to you. Take care.
Thank you.
Bye-bye now.
Bye.
Ciao.